Okay, so hello everyone. In this video, we will cover topology. As we discussed in our last lecture, that what is the role of topology in physical layers. So we will discuss it in details here. So in this video, we will discuss about mesh topology, star topology, bus topology, and ring topology. And then we will discuss about its number of cables, number of ports, reliability and security, cost and communication type. Let's begin. So what is topology first of all? First of all, topology refers to the arrangement of devices and connection within a network, impacting its performance, reliability, and scalability. So, a topology essentially describes how devices are interconnected. It's about the arrangement of devices in a network. Okay, first of all, we have mesh topology. In mesh topology, what do we have? In this setup, all devices connect directly to every other device, as we can see it in diagram also. Let's say there are four devices, each has a direct connection to the others, forming a fully interconnected network. For 5 devices, the connection multiplies similarly. Now, the question is, what is the cable count of it? Okay, so in this diagram, it is simple to guess, like we can easily guess that 4 devices, then we can count it to 6 cables. But what if there is like 10 to 13 devices? For that, we use the formula n bracket n minus 1 upon 2. So this is the formula where n is the number of nodes, or we can say n is the number of devices. So let's say we have 8 devices. In question, that is given that you have 8 devices. Now tell me the number of cables count. N equal to 8. Okay, so in formula we are putting it. So 8 bracket 8 minus 1 upon 2. So we will get 56 upon 2. So what is the final answer? 28. 28 cable is our answer. Okay, now moving forward to number of ports per device. Each device needs n minus 1 port. What is n here? N is number of devices. So for let's say 4 devices, there will be a need of 3 ports per device. Total 12 ports, and we will need 3 ports per device in mesh topology. Okay, so now moving forward to reliability of mesh topology. Reliability is another crucial aspect. It offers the highest reliability among all the topologies. We have mesh topology, bus topology, star topology, ring topology. So it is the highest reliable topology ever, mesh topology. Because let's say there is a link which fails. Okay, so if one link fails, say like in diagram we can see here also, that if A to D connection fails, then we can send the message via C or via B route. So we can choose alternative paths. Alternative exist here. This is highly reliable. What do we mean by reliable? It means like if the one device or one connection fails, then our topology, our system should run. This is the reliability. Now moving forward to the security. Secure mesh topology is very strong secure. Like we can say security is strong because communication between two devices isn't visible to others. Like there is no other device involved here. Like let's say A want to send a message to D, there is no device involved here. A can directly send a message. Mesh topology is strongly secure. There is direct communication. Okay, and there is no device involved in between two devices. Now moving forward to the cost is very high in mesh topology. Why? Let's say we have 10 devices. Okay, so it will require 45 cables. So because of these cables, due to excessive cabling, the cost is high. The next is communication type. Mesh topology supports only point to point communication, not multicast. What do we mean by point to point here? It means there is no other device involved. Like I have mentioned it before, that there is no device involved while we are sending message to A to D. So there is no device involved. So there is point to point communication. We can say one device is sending a message to another and there is no other device involved. This is not suitable for multicasting, only point to point communication. Now moving forward to another topology, star topology. In star topology, a central hub is there. Like we can say all devices connected to a central hub. Now what is hub? We will make a separate video on it, that what is hub, what is router, what is switch. Hub is a multi-port device. Like hub has multi-ports. Okay, now moving forward to star topology. In star topology, all devices connected to a central hub. If device A wants to communicate with C, the message goes through the hub and now the hub will broadcast it. So moving forward to the cable count. How many cable we will need? So we will need n cables for n devices. Like let's say there are 10 devices, so we will need 10 cables. You can look at it at the diagram also. Each device only has one cable that connects it to hub, and also each device needs just one port while the hub has multiple ports. Now moving forward to reliability of star topology. Reliability is very lower because the hub is a single point of failure. If the hub fails, the entire network goes down. Let's say in this diagram, hub fails. So what will happen? The entire network will go down and our topology will not work. The reliability is very low. Now, moving forward to the cost is very moderate, because here in star topology we need less cabling than mesh, but hubs can be expensive. Okay, we need a hub and hub can be expensive, so we can say cost is moderate. Now moving forward to the security is weaker since the hub broadcast message to all the devices, because if we broadcasting message to all the devices, our system is not secure, our topology is not secure. Hub will send that message to all the devices. What do we mean by broadcast? Hub will send the message to all the devices, but the devices which has the same destination address can receive that message. Okay, that's why star topology is less secure. Moving forward to the communication type, like mesh topology, star uses point to point links between devices and the hub. It will not use multiple connections and all. Communication type is point to point. Now moving forward to the next topology, which is bus topology. Bus topology features a single backbone cable, like we can see it here in diagram also, that in bus topology we have backbone cable, we have drop line which is connecting devices to the backbone cable, and the tap which is connecting drop line and devices to backbone cable. Okay, the drop line is connecting device and tap. This is the diagram, and at the end we have repeater, or we can say terminator. Bus topology features a single backbone cable. This cable can be coaxial cable or thick ethernet cable with devices connected via drop lines. Okay, drop lines are cables which is connecting devices to backbone, or we can say main cable. Okay, and now what is tap? Tap is connecting backbone and drop lines. So now moving forward, number of cables include one backbone cables plus n drop lines. Let's say we have 10 devices, then we will need 10 drop line also, and there is backbone cable, so the count of number of cables is 11, n plus 1. Now moving forward to the number of ports, each device needs one port. Moving forward to reliability, bus topology is very less reliable, very poor, because if the backbone cable, the main cable, is transferring the data, it will fail, then our entire network will crash. Okay, so reliability is very poor because backbone failure can crash the whole network. Now moving forward to security is also very weak in this bus topology, as all devices see all transmission in bus topology, so this is not so secure. Now moving forward to the cost is low. In bus topology there is an advantage of cost. The cost is very low in bus topology. Now moving forward, we use terminator or repeaters at cable ends. Why we need a repeater or a terminator? In last lecture we have discussed that repeaters will improve or will boost the signal length. Let's say we have a backbone cable of 500 meter and we want to increase it by 500 meter more, so we have a 1 kilometer long backbone cable, so our signal strength will decrease. So at the end of 500 meter we will add a repeater to it, then it will boost the signal strength again. Now moving forward to collisions are a major issue here, because all devices share the backbone, and let's say all the devices has started sending message as one time, so there will be a collision. Okay, so to reduce this collision, we can use CSMA CD method, or let's say token system method. Okay, now moving forward to the termination, we require terminator or repeater at cables and for signal integrity. Now moving forward to last topology, which is ring topology. It is almost as same as bus. Assume it like we are connecting both the end of bus topology, so it will create a ring topology. Okay, it connects device in a closed loop, often with one device acting as a monitor. In this, here we have two diagrams. Okay, before moving forward, please notice one thing here, that there are two diagrams of ring topology that you will find on internet. Okay, these two are showing up on screen, so don't confuse about number of cables and number of ports between them. Okay, in first diagram there will be n number of cables, because there are not any drop lines as we seen in bus topology. Okay, and in second diagram, cable count is similar to bus, n plus 1, the backbone cable and the drop line cables. Okay, so the number of cables will be, for first diagram is n number of cables, and for second diagram there will be n plus 1 number of cables. Okay, now moving forward to number of ports here. So in first diagram there will be 2 ports per device, in and out, and for second diagram each device will have 1 port. Okay, moving forward to security is weak as messages circulate to all devices. Okay, now moving forward to the cost is very moderate, as same like similar to the bus. Moving forward to collision handling, one more thing here is the token ring. Okay, so the token ring system helps reduce collision. Like we have seen that in bus topology we used the CSMA CD and token system. So in ring topology we will use token ring system. That was all about the topology and all things. So that's it for this video. We will meet in next video. Until then, bye bye.